engineer can work on. And even if you don't recognize the terminology, don't worry about it. You end up learning so much in the PhD anyway that I wouldn't want that to scare you away from a particular field just because you're not familiar with that terminology. No matter which way you're going, the start tends to be the same place, which is the screen that I've got here, which is a web search. It's the same place that I go when I don't know what I need to learn for a particular field. The idea is to come up with sort of a starting point that you can dive into the academic literature at, and that's where just a basic Google search comes in just fine. So for the example that I had planned for this workshop was one that I need to learn about a little bit for CENG4, which is molten carbonate fuel cells. So some fuel cells work roughly at room temperature, and those are the ones that I'm familiar with, but I don't know much about molten carbonate fuel cells. And so I might end up doing a literature search to learn more about molten carbonate fuel cells. I don't know anything really about molten carbonate fuel cells other than the words molten carbonate. Oh, by the way, okay, yeah, it's recording. I was going to ask you if you're recording, but I see the little dot down there, so I think we're okay. So along those lines, when I'm just starting off with a topic that I'm trying to learn more about, the particular class of papers that I usually go to first are called review papers. And so the review papers sort of sit over here as one class of article. The other articles over here are new research, right? New results, new findings that groups have worked on and found and written up. Review papers are different from that. They're not often cited as original research because most of the time what a review paper does is assemble and collate and organize and offer a connecting narrative to research that's already been done by other people. Usually review papers come out maybe like 10 years or so after a particular field has developed. There's probably 20 or 30 core papers in a particular field, and those review papers are being published to highlight not just what has been done, but also where the challenges are. And so make it to your point about, we need to learn about a new mechanism or something that we could use for, chemi cars or a chemi project or something like that. I think you would probably be best served starting at finding these sort of review papers. They're easy to find because they usually start with the word, the word review is held in there somewhere. And they're also where I tend to start, even if I'm trying to dig into a more specific area, because they have such a broad overview of a particular discipline that it's very likely that you'll be able to find something in there that is useful to you. So if I was going to start with that, I have not done any research on molten carbonate fuel cells, so we're going to go through this all together. I haven't done this before, but I know that a good place to start is something like a review. So I'm going to type review of molten carbonate fuel cell, right? And I'm just going to see what Google comes up with. Google Scholar articles are a great place to start. I usually don't go down into things like Wikipedia is not really that great for what we're trying to do. Wikipedia is great if you're trying to get sort of a really quick overview of, I don't know if what I'm talking about is a molten carbonate fuel cell, or maybe it's a catalytic fuel cell or something like that. But at the depth that we're going to try to dive into, Wikipedia tends not to be a good source of the types of documents that we need. Any other kind of website that you go to that has articles, like journal articles, it has a chance of being pretty good. But I got to say, a good place to get started is usually the scholarly articles up here on Google. And again, I'm looking for a review that has something to do with molten carbonate fuel cells. And at this point, we're only reading the titles. The reason for that is titles are supposed to be pretty descriptive. You don't want to, I guess this is more on the authors than on the readers to do, but when you're generating your title for your paper, you're doing it in such a way that you can attract the attention of the correct audience. And so you can sort of rely on these titles to be relevant to the material that's in there. So for example, in this first one that they happen to mention the stability of molten carbonate fuel cell electrodes. Right away, I kind of get that that's going to be too specific to me because I'm still trying to figure out what a molten carbonate fuel cell is and sort of how it fits into that greater ecosystem. I do not care about electrodes yet, or their stability. Again, here, dealing with fuel contaminants for a particular molten carbonate fuel cell, probably a little too specific. Here's a technological status of molten carbonate fuel cells. So again, these are all a little bit too specific for me. But here I come across one. This one looks like it could be okay, right? A review of fuel cell and energy cogeneration techniques. And I noticed that molten carbonate fuel cells happen to be included as part of this review. So this is going to be, I don't want to call it my seed paper because I have another definition of what I mean as my seed paper, but maybe this could be like my springboard paper, right? This is where I'm going to go first to try to figure out everything else about this field, or at least get my bearings, right? So to figure out whether or not this is relevant. So review papers are a great place to go for something like this. I'm going to go ahead and click on this one. I don't know where it's going to take me, somewhere over to IEEE Explore. And the next thing that I'm going to do is read the abstract. The vast majority of the times that you look for a paper, you will never have to go deeper than an abstract. Most of the time, the abstract will tell you, stop reading this paper. And that's not like the fault of the authors or anything, right? They are trying to write an abstract in a particular way that gives you the information that you need right up front so that you can make the decision to read that paper or not. Before we actually read the abstract here, I want to sort of show you the value of an abstract by showing you how they're supposed to be written. They're not all written this way, but they should all be aiming to be written this way. To figure out how an abstract is supposed to be written, we're going to use the work of Celia Elliott. So if you Google Celia Elliott, how to write an abstract. Celia Elliott is a woman who worked for, I believe, the University of Illinois. I could be mistaken there. And she has just like resource after resource after resource of how to do everything how to write anything in academia, how to write an abstract, how to write a paper, how to give a presentation. Although I have found I take small issue with some of the things she says in presentation, but they're still pretty solid. How to write grant proposals, how to write applications to fellowships, that sort of stuff. She's got like 30 years of experience doing this. She's a fantastic resource. And so I want her recent work on how to write an effective abstract. Let's see here. Effective Abstracts by Celia Elliott. Yeah, she was at Illinois. So I'm going to click on this one. Let me just make sure that this is the one that I want. Yep, this is it. This is what most of her notes look like, right? They're summaries of presentations that she has given to other universities or other programs. And I'm going to scroll down to her outline for how to write a good abstract, which is, she abbreviates as MMRC. Let's see, where is MMRC? This is good, right? If you ever come across an abstract that has figures, tables, references, complex equations, or acronyms, chuck it and go on to the next one. It's probably not a very well-written abstract. It should not be fluffy. Come on, where's your MMRC? Read it. Oh yeah, that's the Hall of Fame. This is good enough. Maybe she abandoned her MMRC afterwards. Here's the 4 distinct elements that are in the abstract, which is the same as the MMRC acronym that I was recalling. It should have a concise statement of what you were studying, what the approach is that you used. This is the most important one, which is a description of the principal results obtained. This is one where that really separates, I would say, most people in STEM from, think of like an author or something like that, right? Like a mystery writer. People in STEM are generally not supposed to be writing things that read like mystery novels. So, you know, if we were writing a murder mystery, it would be an absolutely terrible book because you would go to the abstract and like the second or third line would say, the butler did it. and the main result is just sitting right up there inside of the abstract. It's not supposed to be a sentence like, we will reveal who killed X, right? It's just supposed to say right up in the abstract, the butler did it. There's not supposed to be mystery or anything like that. I know it can make for more entertaining reading, but it is not more informative reading. And the reason for that is most people read the title first and the abstract second, and they never get any deeper than that. So if you're trying to show to your readers that you are a mystery writer, they're just going to skip your paper because they probably don't have time to read something like that. For us, on the other end, as the reader, we're going to leverage that guidance to say, I'm not going to read any deeper than an abstract. If I can't figure out whether or not I should read this paper in the abstract, it goes in the trash pile. And I skip it and I go try and find another one because there's lots of papers out there. You may end up coming back to that because you got pointed to it from a different paper, but at the very least, we're going to skip it if its abstract doesn't tell us what we need. And then the last one usually goes along with that, which is a summary of the conclusions that are reached, which tends to be similar in a lot of cases to the description of the principal results. Usually conclusions are, how do we interpret these results? What do they mean for other fields or for our own field? But the one that we're really looking for to begin with in the abstract is a description of the principal results obtained. For a review paper, if we take that idea and go back over to our review paper, the principal results are a little bit different for a review paper because they are generally going to try to tell you what they are reviewing in that paper. And sure enough, if we look at this review of fuel cell and energy cogeneration technologies, the very first line says, current fuel cell technologies are reviewed and emphasis is placed on their use in a combined cycle of heat and power. At least for me, that is exactly what I need because the reason I'm after a molten carbonate fuel cell is to know how it fits into UCSD's microgrid facility, which also includes a cogeneration facility. So this sounds exactly like what I'm after. Some of the other things that they talk about on here, not generating polluting gases, low levels of noise, those are okay. But I'm also reading underneath here that they're going to talk about alkaline fuel cells, PEM fuel cells, microbial fuel cells, and the one that I'm really interested in, molten carbonate fuel cells, will be in there. Again, that's exactly what I'm interested in because I would also like to know where this fuel cell fits in the greater context of these types of technologies. So it sounds like this review is going to be what I want. I got to admit that that's a little bit faster than this usually goes. It usually takes me about 30 minutes or more to find this first good paper that I have some hope for. We kind of got lucky here. I promise I did not Google that ahead of time. We just got lucky that it happened to work out this way. Generally, if you can find a good paper that's got something that sounds reasonable for you in the abstract, that's close enough. And you can sort of go on to the next stage where you stop using Google and you use a search technology that's a little bit more specialized just for finding journal articles. And from there, we can start to dig a little bit deeper into each paper. And that'll be sort of the next thing that we do is, how do we find these papers once we know that we are interested in them? And then how do we use them as a springboard to learn about more papers? I'm actually going to go in reverse order here and say, how do we find out more papers relevant to this one? And then we're going to come back to this one and learn how do we read these in a little bit more depth. And actually, I might pick a different one to learn or to show you how to read them in more depth because, again, a review paper isn't usually presenting novel results. And so reading them is a little bit more front to back, right? You just find the section you're interested in and read about it. Most papers aren't written that way, so maybe we'll just come back to the review paper later. But it is nevertheless a good place to start to show you this other tool that I want to show you how to use, which is once you get one of these papers, how do you do better than just a Google search, right? Presumably you're in the right ballpark. Maybe you need a different paper that was cited by those authors, or somebody else came along and cited that paper and you'd like to know who that was, because presumably that network of citations is showing you the people who are working in this field. And there are some pretty good tools that will help you figure out that network of citations. This, by the way, is where you're going to need the VPN. So everything we've done up until now, you can get away with on any public network, you'll find it just fine. But the tool that we're about to use requires access to UCSD's IP system. So if you're not on the VPN or you're not on campus, you may not be able to follow along on your computer with what we're going to do now. The tool that we're going to use that's a little bit better than just straight Google searching is called the ISI Web of Knowledge. So I'm going to Google ISI Web of Knowledge. It should be the very first link that you have up here, and I'm just noticing they still have not figured out what they want to call themselves. Their website is webofknowledge.com, but they still call themselves the Web of Science. It's the same thing. That's the one that you're after, is webofknowledge.com. So I'm going to click on that one. If you're on the VPN, it should just push you right through to this search screen. If you're not on the VPN and you click on that link, often it will take you to a login screen. We don't have any login credentials. That's supposed to be handled by our IP address. So if you're getting a login, it just means you're not on the right page, right? You don't have the VPN hooked up right or something like that. This is the Web of Science, and this is generally the best. I don't want to say generally the best. It's a really good resource, and it's one that I would encourage you to try first because it's so useful. What makes it useful is, A, it's designed to find journal articles, and so the search fields that are available are tailored to journal articles. So for example, if we want to try to find this review paper, certainly I could just click on the PDF right here and that would be fine. But let's pretend that we couldn't do that, right? Just to demonstrate how to use the Web of Science. Usually you need three things. You need 2 authors and a year. If you know 2 authors and a year, that's probably enough to find the paper that you are looking for. Usually I try to find the authors that have just a first name and a last name. If you come across a name like this that has 4 parts to their name, you'll probably still find it. But some of these archiving networks change the way that, or they don't have consistent ways of handling what's a middle name, what's a surname, what's a first name, what's a given name, what's a last name. And so often if you can just find somebody that's got a 2-part name or 3-part name, you'll have more luck locating their paper. But I mean, you're almost guaranteed to find it even with the 4. You just might have to look through an extra 2 or 3 papers. So if you personally are in the habit of publishing with a 4-part name, don't worry about it. People will still find your paper. You don't have to change your name or anything like that. So I'm going to use this one as the first one. Let's see if I can, there we go. I can select just that one. Go ahead and copy that one. And I'm going to come over here to my Web of Science, and I'm just going to change from topic to author and paste the author name in there. And I'm going to add 2 more rows over here and switch this one to an author and this one to year published. And I'm going to go snag another author over here. Let's go ahead and try this 4-part name over here. Let me see if I can grab that one. Boy, it's hard to grab that without actually clicking on the link because I don't want to do that. There's my second one. And then the year published should be right up front somewhere. Let's see, that's 2008. Yeah, we'll try 2018 and see if we can find that one. 2 things will generally happen. 1, you'll find the paper, and 2, you won't find the paper, right? Those are sort of mutually exclusive outcomes that cover the entire experimental space. Either you'll find them or you won't. I'm curious if we're going to be able to find this one or not, because it is a paper that was published at a research congress, which sometimes those get plugged into Web of Science and sometimes they don't. But let's see what happened, right? Like I said, we're researching this topic for the first time together, which will show you some of the ins and outs. I haven't tried these kinds of searches before, so let's see what we can do. Perfect. So we came up with 2 results, which is great, right? If I were to Google the same thing on, let's just find out on Google. Go to google.com and get the same, whatever. Anyway, take my word for it. If you Googled that, you'd probably get way more than 2 results. I don't need to show you how many results you get on Google. You know what I'm talking about. Right away, the first one is not it. It was actually written by the same people in the same year and published similarly, which, by the way, is a game that some people will play of trying to publish the same thing twice, which you're not supposed to do. But sometimes people do it. It looks like those are separate enough that they're probably different. But sure enough, our second one down here is the paper we're after, which is a review of fuel cell and energy cogeneration technologies. If we wanted to actually get that paper through the ISI Web of Knowledge, the button you need to click is called the UCI Links. If you just want to know more about that paper, the abstract should be included here, and you can click Show Abstract or Close Abstract. It's not always included, but a lot of times it is, right? So you can look at the one above it. This one was not listed with an abstract, so it's not there. But here's the same abstract that we read before. And so once I switch over from the sort of general Google search into an ISI Web of Knowledge search, I can get the abstracts right here. And that's frequently all I need to do is check titles and then open or close the abstract on here. And it's got all of the information neatly put together in one location. Like I said, if you actually want the paper, you can click on UCI Links here. My guess is it's just going to open exactly the same page that we were at a moment ago. May not be available online. Check for it here. Sure, let's try Roger. See if we can get it through Roger. Nope, seems not to be available. If you can't find it through the UCI Links, then you can just Google the title of that paper, and sometimes you'll get lucky and be able to find it some other way. And sure enough, now that we have the title, we are back to, we've sort of connected that circle, right, of where do I actually find this paper? Here it is again, right? We've come back to that same page. Again, the reason that we put that into the ISI Web of Knowledge in the first place was just to demonstrate the search feature. You would not usually run in a circle like this, right? You just get the PDF if you need it. But that was just to demonstrate how you might go about finding that paper. The real benefit of the ISI Web of Knowledge is to figure out what sort of came before that paper that was relevant to that topic and what came after that paper that was relevant to that topic. In order to do that, if you click on the title of the paper itself in ISI Web of Knowledge, so this A Review of Fuel Cell, I'm going to click right here. And there are two really important numbers on here that can say what came before this and what came after this. The things that came after this are part of what's called the Citation Network, and they're sort of the forward-looking citation network, right? What are the things that within their paper thought that this particular paper over here that you're reading about right now was relevant enough to their information that they are going to cite it and say there's something important in there. Most reviews tend not to get cited a lot. Every once in a while, you'll come across a review that just has like thousands of citations. That's a little bit less meaningful than you might think, because often those citations are along the lines of somebody types in, you know, for an excellent review of fuel cell and cogenerations, please go see blah, 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 right? They don't really talk about what these people found. They're just sort of saying, you know, an excellent review is over here. So it's less useful for us because we're starting from a review paper. But nevertheless, if I click on the big number 5 over here, that's all I have to do to find everybody who has ever cited this paper, at least within the Web of Science or the Web of Knowledge. That tends to be an awful lot of papers. It can miss a few. There are articles and journals that are not included in the Web of Science. So it's not everything, but it's a really good chunk. I would say probably 75% or more would be inside of the Web of Science or Web of Knowledge. And so here is where I can now start to look, you know, sort of forward and say what came after this review paper and see if any of these are particularly relevant for my idea of looking into molten carbonate fuel cells. Again, I'm going to start with titles and see if the titles are particularly relevant. Again, they're trying to be as descriptive as possible in their titles, so I'm going to rely on those titles to tell me what the main idea of that paper is. This first one is talking about generally a microgrid. They don't seem to mention molten carbonate fuel cells anywhere, so probably going to skip that one. Gas energy storage system in peer-to-peer community energy market, again, probably not relevant to me. Wireless sensor networks, right? You kind of wonder what these people had to do with our original paper of a review of fuel cell and energy cogen technologies, it's probably a sentence somewhere in that paper, like, an excellent review of fuel cell energy cogeneration is blah, blah, blah. So, it's not surprising that we're kind of striking out here in the forward-looking direction. Energy management, maybe. Mass transfer and power loss in proton exchange membrane fuel cells, no, nothing really helps me there. So we've sort of gone in, hit a dead end of looking forward, right? For papers that have cited the paper that we're reading about right now, not much. Doesn't seem to be much that we're interested in. That's not at all uncommon. You hit a lot of dead ends when you're doing research, especially through journal articles. So don't be discouraged just because you hit a dead end like that. My guess is we're going to have much more success looking backwards, right? Remember, if our paper is sitting here in the middle, what we just looked at is all of the papers that came after that paper. What we can now look at is all of the papers that were cited by this paper, which is all of the papers that came before the one that we're interested in. That is the second number down here in the citation network, which is the number 51 for cited references. So everything that was cited inside of this review paper is in that list of 51. So I'm going to click on that. This one, I would hope that we can figure out, hey, I know a guy that works for I'm going to go ahead and call him my best friend. He graduated with me from University of Akron in Ohio, and we sort of went different ways for our PhDs, but then he went to work with Watt, and he was actually he wasn't quite the founder, but he was in there when Watt had like 6 people working for him, and he still works for him. Hold on. I got to make a note to go contact him and let him know that I came across him in a random search. He will just be tickled pink that he showed up. That's so cool. Anyway, back to the purpose of the workshop here. Let's try and look through the papers that were cited by this particular paper, the one that we were looking at. And it doesn't look like, let's see, tools. I'm trying to find my, I don't want to find really, it looks like they got rid of my favorite button, which was to change the way that the search results are provided. Maybe if I just click on search results, it'll tell me what I want to know. No, that took me in the wrong direction. 51. I guess since it's just 51 and it's only those which were cited by that paper, they're not going to let me sort them. At any rate, now I can start looking through them. I have a tendency to ignore the ones that are in black and go for the ones that are in blue, because the ones that are in blue, I can usually see an abstract for them. The ones that are in black tend to be conference proceedings or something like that. This one was noted in a bulletin, which I have to give my friend Matt crap about posting in a bulletin because people can't read it there. I tend to look for the ones that actually have abstracts. But again, I'm going to be looking at primarily titles to see which of the titles could possibly be interesting. I'm going to, if I were doing this for myself, I would be looking for one thing. I'm going to look for a title here that can help us go sort of the next step in depth when it comes to reading journal papers, that can actually be used as an example of how do we read a journal paper. So I'm going to skip this one because it's a review, and reviews read a little bit different than most papers. And let's just kind of go and see if we can find another one. Modeling of simple hydrogen, solid oxide's not bad. I don't even know what a listening and sleeping mechanism is, nor how it has anything to do with a wireless mesh sensor network. Solid oxide fuel cell waste heat seems like it could be getting a little bit closer. Microbial fuel cells for pollution treatment. That could be one place that you could go if, for example, as Mahika had mentioned at the beginning of the workshop, if you're looking for whether or not something could potentially work for a problem that you're trying to solve, that could be one. I'm going to kind of flag that one in my mind and possibly come back to that here in a moment. But again, actually, this would be a good time. Let's look at the abstract here. So it gives us a brief overview of what an MFC is, a molten carbonate fuel cell, or sorry, microbial fuel cells. But here, okay, great. The abstract has told me don't read this because this mini review provides a bunch of stuff. I'm not interested in another review right now, right? I'm trying to find a paper that's actually going to present new results. So as I had mentioned earlier, the abstract is usually about as far as most people go in papers, because right away knowing that that's a review means that I don't need to read that any further. It's not going to help me in what I need. Ooh, here we go. Optimization of molten carbonate fuel cell, good. This other thing, I don't know what that is. And then distributed power generation, getting a little bit closer. Let's keep going just to see what else we could find. Numerical thermomechanical modeling of solid oxide fuel cells. That's probably going to hit pretty close for what I'm interested in. And it was also, you can generally get an idea of how widely applicable a paper is to an extent by the number of times it was cited over here. Generally, if something is cited like maybe 10 to 15 times, that's good enough to take a look at it and say, they might have found something that's particularly relevant. If you come across a paper that was cited like 600 times, like this one was, dollars to donuts is probably a review paper, which is not a bad thing. Review papers are perfectly fine if they get cited a lot, but there are just fewer papers that tend to be cited that many times that are presenting new results, right? Most of the time, those super highly cited papers tend to be review papers, but there's a few in there that are sort of the first papers in a field that will have that many citations. I'm going to remember this one. Keep the number 29 in your mind. I think that's where we're going to go next. But let's just check page 2 of the results. Unlike Google, you should keep going through the results. Just because you get to page 2 in an ISI search doesn't mean that the results are crap. The papers are all good, right? Remember, you're looking at everything that was cited in that paper. They're not organized by how relevant they are. They were just cited in that paper. So don't neglect higher pages in an ISI search because they can be very useful as well. So let's just take a quick look through here. Looks like a lot of review papers in here. Overview of fuel cell technology. Not going to help me very much. Overview, again, a little bit too broad for me. Global Reforming Kinetics could be a place to go. It's in Chemical Engineering Journal. That might not be too bad. Actually, yeah, let's dig into that because that has methane in it. That'll be a good one for us to dig into. Fuel cell technology, probably too broad. Fundamental aspects and prospects. I might go into that if I'm trying to learn more about it. Again, those review papers are excellent if you're ready to try and find out where your paper sits in the broader landscape. I don't want to read those because they're not going to teach you how to actually read a paper. Let's go ahead with this methane steam one. I'm going to check the abstract here just to verify that this is actually presenting a new result. Okay, they're given some motivation here. Planar electrodes. Okay, they actually built these electrodes. It says here that these two electrodes were built to investigate the kinetics. So that is telling me that they're actually generating new results. And then down here, they're going to tell me the results confirm the proposed kinetic expression to an Arrhenius type order, which is great. If you think back to 113 or you haven't been in 113 yet, Arrhenius is pretty easy to use. So I'm not worried about utterly bizarre kinetics. That's really good. And they even talk about a little bit of off-gas recycling. And then they have given, as Celia Elliott suggests, a little interpretation of their conclusions because they're talking about this activation energy corresponding to a desorption energy over here. Great. I'm not that into any of this field, so those words don't mean a ton to me right now beyond what I generally interpret them to mean. But it sounds like this could be a good paper to learn more about the kinetics inside of a methane fuel cell, right? A solid oxide fuel cell, which is a molten carbonate fuel cell. or even if it's not. Actually, I think they are different. At any rate, it'll be a good paper for us to figure out how to read a journal article. So I'm going to click on UCI Links here, try and grab that. And I will actually try and put this over in chat. I'll put the link to it in chat in case you weren't able to track down the one that we want. If you are on the VPN, this link should take you directly to the paper that I'm looking at right now, and you should be able to grab it. I'm going to go ahead and download this because I'm relatively sure that this is the one we're going to use. These readers on here, every publisher has their own type of reader. Some of them are good, some of them are terrible. I'm just in the habit of actually downloading them to my computer and reading them in Acrobat because there are certain tools in Acrobat that are useful, and I want to be able to use those. So I have downloaded them. I'm going to open them with my system viewer, which is Acrobat, and throw Acrobat on here for a moment. Again, the link that I just put in chat should take you right to this article if you want to follow along with it. I apparently just checked an option and it didn't actually open it. So there we go. Now we're open. I'm going to put this window over here and resize it for you. 16. There we go. So the sort of third part of this workshop, the first part is how do you get started? Google searching is usually, or Bing, if you like Bing. General searching to just try to find a paper that sounds vaguely related to what you're trying to do. Review papers are good places to start. The second step is, once you've found that paper, how do you dig into that field a little bit more? That's where ISI Web of Knowledge comes in. Right, and you're primarily looking through titles and abstracts, and you don't get too much deeper into individual papers. Once you've found an individual paper that you're interested in reading, that's where knowing the structure of the paper comes in handy. They're all generally structured the way that the bookmarks are showing over here, which is the abstract comes up top, which if you've looked at any journal article, you've always seen the abstract up top. And then they're usually accompanied by some combination of introduction and background. So sometimes intro and background are all one section. Sometimes they have separate intro and background sections, as they've got here. The thing that follows the intro and the background kind of depends on what that paper did. If it was a computational study, they might be talking about the models that they used. If it was an experimental study like this one is, they're probably going to talk about the reagents that they used, the equipment that they used, the types of measurements that they made, that sort of stuff. And then coming after that is, again, it can be either separated as a results followed by a discussion section. Sometimes they combine the two and we get like a results and a discussion like what we've got here. And then the last one tends to be conclusions. The order of reading these is a little bit chopped up, right? Presumably by the time that we get to the stage of, I found a paper that I'm interested in reading, I have already read the abstract. And so just as a reminder, actually there's my highlighter right there, I'm going to highlight in this paper what it was in the abstract that I read that was interesting to me. And remember from Celia Elliott's guidelines on how to write a good abstract, the main result should be up there somewhere, right? This is what attracted me to the paper in the first place. And the thing that attracted us to this paper in the first place was this sentence about Arrhenius stuff. Here we go. The results confirm Arrhenius with second order for different steam to carbon ratios here. Right, so when I'm reading through this paper, I'm going to keep that in the back of my mind. The abstract was trying to tell me what one of the big results from this paper was. I'm going to be looking now for some Arrhenius kinetics. I would also note that often I'm interested in how they did the experiment. This one, they have it, right? They're talking about two specially designed planar steam reformers utilizing nickel yttria stabilized zirconia. Okay, it's a little bit further than, a little bit more detail than I might need, but at any rate, they built their own pair of steam pre-reformers with a particular catalyst. That's great. but the bigger one is this one seems to have some Arrhenius type kinetics, right? So those could be useful for modeling purposes. I'm less interested in this activation energy down here, but the point of highlighting this is to remind you that the abstract is the first place to go to read what it is this paper did. The second place to go to read what did this paper do, right? I don't want to just dive in and start reading this thing from top to bottom because the thing's only 10 pages long, but these things are really dense, right? You don't want to try to really understand a paper in depth unless you're absolutely certain it's got everything that you need, because if it doesn't, somebody else probably does. And so the next thing that we want to do after the abstract is actually go to the end of the introduction. Usually at the end of the introduction is some sort of a transition. This one might appear at the end of the background, but there's a conceptual difference between the introduction and the background versus everything that comes after that. The introduction and the background are usually summarizing what other people have done. The experimental section, or whatever comes after the intro and the background, is usually where the authors transition to, here's what we did. In between those two, there's supposed to be a transition sentence or maybe a transition paragraph that describes in a little bit more detail what this paper found. So I'm going to go searching for that right now. I would say it's there in at least 50% of the papers, but let's see if this one does. I haven't read this one. Here's the beginning of the introduction. I'm going to skip to the last paragraph in the introduction, which is right here. Notice these words, in this paper. That's your keyword, right? You're looking for a phrase like here we show, or in this paper, or just here comma we do something else, right? You're looking for a restatement of what they have found, right? And this is to reiterate to yourself that this paper is going to talk about what you're interested in. Notice the transition, right? There are lots and lots of citations prior to this, right? Citation, 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 3 citations, another citation. Everything in the intro is talking about things that other people have done, and they're backing up their statements with citations to what those people have done. When you start to transition to what you are doing, like in this paper as they have done right here, generally the citations become a little bit less. These folks are a little bit unusual in the sense that they have both an intro and a background, so we'll probably find some more citations going forward. But this is the phrase that you are on the lookout for, right? Something like in this paper, right? A restatement of what they have found. So here again, I get a nice restatement. Global reaction kinetics for methane steam forming at temperature ranges up to 740 C. It's a little concerning to me that this is in a newly built system, because that means it might not be relevant to other people. And so that could be a reason to reject this paper. It was already in the abstract, and we kind of said that wasn't a problem. So I'm going to say that that's okay. Notice that they actually now have gone into a little bit more detail, right? The abstract is very high level. This paragraph, this transition paragraph, is probably the first place where they will start to give you a little bit more information about what they did. So they have also presented, they've just said, the paper also deals with this effect of AOGR. I don't know what that is. We could figure it out. But something has an effect on reaction kinetics, which is great, right? I've learned a little bit more about what this paper is doing. This is another place where you can sort of bail or keep going, right? Either this is what you want or it's not. And that's our transition paper. Oops, moved a little bit too far. I'm going to double check the end of the background just to see if they've got another one in there. Yep, they actually gave us another one, right? They said the objective of the work is to study steam reforming. That's great, right? They're just rewording it, what they found, in another way. This is all great for us, right? We're not trying to learn exactly the details of what they've done inside and out, right? It's not like we're trying to take this and move it over to our own code or our own system. All we're doing is trying to figure out, are we sure that we want to read this paper? Because they can be very challenging to read. They often require you to go search for other stuff in between there. And so that process of read the title, read the abstract, and then find the transition sentences in between, like intro and experimental or background and experimental. That's how you approach reading these papers. There's a third one that you go to, which is conclusions. They should be restating what they have found in conclusions. Notice they are like beating you over the head, or they're supposed to be beating you over the head with what they have found. That is entirely by design. It is normal when you are writing these papers to feel like you are repeating yourself, because you are. So we're going to double check the conclusions down here. Usually the conclusions will go into even more detail, right? The title had very little detail, the abstract a little bit more, the transition had a little bit more. The conclusions are now kind of highlighting all of the bullet points that, if you go back up and look at results and discussion, there's probably a whole subsection on each one of these. So they dealt with some space-time in a flow reactor. That could be good or bad. It depends on what kind of reactor we're dealing with. Methane conversion, right? They're going to talk about its trends up there somewhere. They're going to propose an Arrhenius type expression, which is going to be great for us. They've even got a couple of more bullets over here about whether this kinetic expression is valid, more activation energies, and then even more activation energies over here. Right, so now I've learned enough to know the main goal of this paper was a kinetic analysis. I'm absolutely sure that that's what they were doing. They've mentioned it in the title. They kind of hit on it in the background, right? Or in the abstract, because they mentioned Arrhenius. But now, definitely, by the time I look at conclusions, all they're talking about is kinetic stuff. So if I'm interested in kinetics, this looks like a good paper. If I kind of wanted something else out of this paper that wasn't kinetics, I'm probably going to bail at this point and say there's not enough in here. Where you go from now, if you decide to bail, well, that just means go back to ISI Web of Knowledge and pick another one. If you choose to read this thing in results, pick whatever platform is the best for you and expect to spend probably an hour or two at least just figuring out, are the actual numbers in here what I want? Let alone, how did they come across this? Do I believe these? Are they going to be relevant to what I need? It's going to take you probably an hour or two just to understand exactly what they were doing. There's no grand way to figure that out. I will suggest that most of the time the figures are a good place to start, but not always. Subfigures, they're just crap. A good place to go though is figures, but I can't even give you the same level of confidence that I have in an abstract or a transition paragraph, because sometimes figures are just bad, right? They just throw figure after figure after figure and you can't figure out what's going on, but that's not a bad place to start. Otherwise, it sort of depends on what you're trying to get out of the paper. Do you need a kinetic model? Do you need to know the experiment that they were doing because you want to do a similar one? It just depends on why exactly you came to that paper. Excuse me. For my own purposes, for learning about molten carbon and fuel cells, I would have bailed after I read the transition and figured out that this was more to do with kinetics than an overview of how things worked. But that was supposed to be a review of, how do you dive into these papers? Always giving yourself that chance again and again to get a better understanding of what they're going to talk about in experiment and results and discussion before you actually read it, right? So you kind of jump around. You read up at the top, jump to the end of intro or end of background, and then jump all the way down to conclusions. And if all of that checks out, go ahead and read the paper. If something in there is amiss and doesn't seem like it's relevant to what you want, maybe make a note of it somewhere. That's not a bad idea, especially if you're going into academia. Just make a note that this is a great paper for kinetics on so-and-so, right? And sort of have a running spreadsheet somewhere so that you can find them again, right? It's a terrible feeling to have something in the back of your mind like, I know I read a paper about that, I just can't remember which one. At least if you've made it this far, make a note of what it was so you can come find it again. But at this point, after you read those sections of it, you should have an idea of whether or not you want to bail or if you want to dig into this paper a little bit deeper. And I have actually wound up exactly at the time that I wanted to. It's 8 o'clock. That's my best advice for how to read the papers. Is it's really hard to figure out where they're talking about stuff, but it comes in those three particular areas, right? Abstract, transition paragraph before like experiments, and conclusions. And you kind of want to read them in that order and let those guide you when deciding whether or not this paper has what you need it to have. Otherwise, if you just try to read these things from top to bottom, you'll make really slow progress. Don't feel bad. They will never know that you're chucking their paper because it's not relevant to your stuff. It's done in the privacy of your own home. So they won't know that you think their paper is crap. For example, these guys misspelled acknowledgements. That's a big red flag in my book. But whatever. So I want to stop talking now. I know it's 8. I've got another. I can probably hang out for like another 10 or 15 minutes. I'm happy to answer questions on there, but I think I've hit everything that I want. Right? Remember, Google ISI Web of Knowledge for once you're inside of the area that you want, and then once you've actually found a paper, abstract, transition, conclusions in that order. And if after all of that you are still interested in that paper, that's when you can sort of sit down and start the really lengthy work of actually understanding the paper. There's nothing I can do to help you there because, if you don't know what an ln of k versus 1 over t plot is, you'll just have to review it, in the best way that you can.
Cool. Thank you so much, Dr. Drews.
Yeah,
Does anyone have any questions?
Sure, you're welcome. To everybody in chat, I'm just thanking everybody who's saying thank you.
Oh, yeah.
This actually looks like a nice paper. Like for me, I think I might make a note of this just for Senge 113. If you guys haven't taken Senge 113, this might come up because they've got some nice plots here that we could use.
Oh, yeah. I remember those.
My biggest gripe with these plots, can anybody guess what my biggest gripe with this is? It's not stylistic. They're missing a critical piece of information. Can anybody guess what it is?
The title?
No, the title's actually not supposed to be there because the
Oh.
figure is the equivalent of the title. Now, there's actually something missing from the data set that's on here.
Is it the units? Or is SLM a unit? I'm not sure.
Yeah, SLM stands for standard liter per minute. So it's like a normalized gas flow. But you're close, right? This 25.01, I'm really suspicious that they can actually measure that to 1 part in 100 because that's a gas flow rate. But more than that, the thing that brought me to this, let me see if I can find my markup right here. Every one of these should have an error bar on it. Right? There is no way in the world to know how close these values are, right? Are these two actually the same value? Because they are really close to each other. How do I know how close they are? The only way to know that is through an error bar. So I'm immediately suspicious of their results because they don't have error bars on them. Sometimes that happens, right? I might have to read through, maybe there's another plot and they say something like, error bars were omitted because they're smaller than the data series, or all errors are 5%, which is, again, a red flag. That's never right that all errors are 5% because that just means you didn't do an error analysis. But it's sort of a red flag that there's no error on these things.
So would that make like this paper less credible?
Yeah, that one hurts here because they know about it, right? If you look down here, they know they're supposed to put error on stuff.
Okay.
So they've put the error on the slope, but they didn't put the error on the actual data points, right? And so if these error bars look like this, then I probably believe that slope, right? But what if they put the error bars on there and they look like this? Well, they all look like that. That's not a real result. And there's no way to know that unless they put them on there, or at least they address the errors somewhere else. So a little bit suspicious that they don't have that. Not that that has anything to do with generally reading papers. But to give rate data and not put error bars on it is kind of sketch. Or what's the new word that the kids use these days? It's not sketch, it's sus, right? Kind of sus.
Yes.
I'm with it. I'm hip. I still know these things.
Okay. Do you guys have any other questions? I think a lot of people left.
Yeah, I think we're down to 4 now.
Yeah.
3.
If not, thank you so much, Dr. Drews. This was really helpful. I learned a lot of things. I'm sure everyone else did too.
Cool. Yeah, I'm glad it was helpful. Glad I could be helpful for it.
Yeah, thank you, Dr. Drews.
You're
Thank
welcome.
you, and have a nice night.
Yep, you too. We'll see y'all later.
Bye.
See ya.
Thank you.